Which of these samples has the largest number of atoms? So let's look at letter A first. There are 99.44 grams of carbon, and 12.01 grams of carbon is equal to 1 mole. And in 1 mole of carbon, there are Avogadro's number of atoms. 99.44 divided by 12.01 times 6.022 times 10 to the 23rd, we get 4.986 times 10 to the 24 atoms total in letter A. Let's see letter B. We're given 30.67 grams of ammonia, that's NH3. On the periodic table, there are 17.01 grams of ammonia in 1 mole. And now we want to know the number of atoms total. So in 1 mole of ammonia, there are a total of 4 moles of atoms. 1 nitrogen plus 3 hydrogens. And then I need to multiply that times Avogadro's number in order to know the true total of atoms. So 30.67 divided by 17.01 times 4 times 6.022 to the 10 to the 23rd, and we get 4.343 times 10 to the 24 atoms. So far A is winning. So B is not more than A. Let's look at letter C. 49.97 grams of lithium. There's 6.94 grams on the periodic table, which is equal to 1 mole. And 1 mole of lithium is equal to Avogadro's number. And so 49.97 divided by 6.94 times Avogadro's number gives us 4.336 times 10 to the 24 atoms. And this is less than letter A, so it's not going to be C. Letter D, we have 115.2 grams of ozone, which is O3, and 16 times 3 gives me 48 grams of ozone is equal to 1 mole. Now, 1 mole of ozone has 3 moles of oxygen atoms, and then 1 mole of oxygen is equal to Avogadro's number of atoms. So 115.2 divided by 48 times 3 times 6.022 to the 10 to the 23rd. So we get 4.336 times 10 to the 24, and this is still less than letter A, so it's not. D, last one, 136.8 grams of fluorine. Fluorine is 19 times 2, so 38 grams from the periodic table, which is equal to 1 mole. 1 mole of fluorine has 2 moles of fluorine atoms. And then 1 mole is equal to Avogadro's number of atoms. And so 136.8 divided by 38 times 2 times 6.022 times 10 to the 23rd. And we get 4.336 times 10 to the 24. And that is also still less than letter A, so letter A is the sample that has the largest number of atoms.